Hello, algebra students. In the back of the room on the wooden desk are two papers for you today. You are to cut them out on the margins. One goes on one page, the other goes on the other, so leave it whole. Page 138, leave it whole, just tape it in. It's going to be tight, but it'll be fine. Page 139, it'll be fine, leave it whole, tape it in. And now you just saw all my answers. In your table of contents, please, we'll grade your worksheet tomorrow, by the way, when I'm here to answer questions. All right, table of contents, page 138, 139, linear and nonlinear functions. All right, so just a little bit of a review. What is a linear equation? Well, it's an equation that's linear. It's an equation that when you graph it, it is a line. A linear function is an equation that when you graph it, it is a line with one output for each input. In other words, there are not two y values that, 3, 1, 3, there's no two x values that repeat. It's not like 1, 2 is one point, 1, 3 is another point. It passes the vertical line test. So a linear function is not only a line, but it's not a vertical line. What is a nonlinear function? It's a function that's not a line. No, it's not. A nonlinear function is a function, so one output, misspelled that, output for each input, one output for one input, not a line, but is a function. An example of a nonlinear function would be something like that. It passes the vertical line test, but it's not a line. For a function to be a linear function, you must be able to write it as a linear equation. What is the form of a linear equation? Oh, that's right. Y equals mx plus b. Given several points, you can graph them, look to see if they form a line. Cannot be a vertical line because that would not be a function. So let's look at these examples. Bottom of your page. Is this a linear function or a nonlinear function? It is a function because it passes a vertical line test, but it's not a line, so it's a nonlinear function. Driving me crazy? All right. The next one, it is a line. It passes the vertical line test. So it is a linear function. The next one, it is a function. It passes the vertical line test. It looks like it's a line, but it's not. It's two lines. And you should know what kind of graph this is because we just did it in section 4E. This is a nonlinear function. It's actually an absolute value function. I'm going to put that under here. Absolute value function. This one, so it has to be linear and a function. So vertical line test, it passes the vertical line test, so we know it is a function. But it's not a line. It's a non-linear function. The next one, is it a function? Not a function. It is a line, but it's not a function, so it's not a linear function, so it's nothing. The next one, it passes a vertical line test, so it is a function. Is it a line? No, it's several lines. So it's considered a nonlinear function. we should know what this kind of function is as well. It's a piecewise function of 1, 2, 3, 4 different lines. So it's considered nonlinear because to be a linear function, it has to be one line. What is slope? Oh, I hear you right now. Slope is rise over run. Okay, what else is slope? Oh, okay. It's the change in y over change in x. What else is slope? It is the rate of change. It's the rate something is changing. The dependent variable, how it changes in relation to the independent variable. In order to be a linear function, there must be a constant rate of change. To be a line, it has to be a constant rate of change because your constant rate of change is slope. So to be a line, the change between any 2 points has to be the same anywhere on that line. Constant rate of change. So does it represent linear and nonlinear functions? To figure that out, find the slope. Is it a constant slope? So you have to look at your change in y, minus 8. My change in x is plus 3. So my slope looking there is negative 8 over 3. That doesn't reduce. Looking at this guy, 6 to 9 is plus 3. 32 to 24 is minus 8. My slope is negative 8 over 3. Oh, look, it's the same. Plus 3 minus 8. My slope is negative 8 over 3. Oh, look, it's the same. So each point it was given, the slope is the same. It's important to look at each change because sometimes they'll do something tricky like go from 3, 6 to 12, 40, 32 to 60, 16. So this change will be plus 6. This change will be minus 16, but when you reduce it, it's the same thing. So this is a linear function because it has a constant rate of change, which is negative 8/3. Let's look at my next example. I'm going to erase that so I have a little bit more space. Change in y plus 9. Change in x plus 2. So my slope is 9/2. Look at my next one. Change of 22. Change of 2. My slope is 22 over 9. 22 over 2. Wait, over 2, which is 11 over 2, which is not 9 over 2. I don't even need to do the last one because I know my slopes are not the same. It is a non-linear function because you do not have a constant rate of change. So figure out the slope. If it's a consistent change between your y and your x, it is a linear function. If it has an inconsistent change or the change is different, your slope is different, can't find the slope, then it's a nonlinear function. All right, so the last section, do these equations represent linear functions? Okay, a little bit ago, we said a linear function has to have a linear equation. What's a linear equation look like? Y equals mx plus b. We know we can have b be 0, y equals mx. We can have a horizontal line, which would be y equals a number. We can have a, oh wait, we cannot have a vertical line. A vertical line is not a function, so it cannot be x equals a number. Does this look like one of my variations? It sure does. It is a linear function. It would have been easier if I just wrote yes. Does this represent a linear function? Okay, so I have to look back. My b is 0, y equals mx. Well, we know that pi is a constant, so your slope is 3.14 over 1, approximately. So yes, it does. That would graph a line. Does this one? All right, my x is in my denominator. In my form, the x is never in a denominator. So what do? Multiply both sides by x. X times y equals 4? Absolutely not. our equations y equals mx plus b. If they're on the same side, it would be y minus mx plus b. Those are not being multiplied together. Those are being subtracted or added, depending on what your slope is. So because your x and your y values are being multiplied together, oh no, it is not a linear function. Does this represent a linear function? I think it does, but I'm going to multiply it out just to make sure it looks like my form. Y equals 4x minus 4. Oh yes, that looks like y equals mx plus b. So yes, it is. So to figure out if it's a linear function, if you have a y and your x, can you get your y by itself with your x in a numerator? If your x ends up in a denominator, it is not a linear function. Homework, page 240, 241, 1 through 14 evens, 16 and 17.